Hello everyone. Today we will solve cycle in a linked list. This will be the second problem in our blind 75 playlist. The question says that there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. For this example, the height is starting at 3. From 3 we are moving to 2. From 2 we are going to 0. From 0 to minus 4, and this is then cycling back to the node 2. Then from 2 it will again go to 0. From 2 it will go to minus 4. So this will keep on cycling till the infinity. Similarly, for this another example, we are starting from 1, we are going to 2. From 2 it is cycling back to 1. Let's take another example which does not have a cycle. Here, if we start from head, we will go to the A. From A, we will iterate to B. From B, we will iterate to C. From C, we will iterate to D. And this will finally iterate to null. So this is the end of our linked list. In case there had been a cycle, there wouldn't have been end of a linked list. There wouldn't have been null here. It would again circle back to any of this node, either B or C. With this example, we can conclude that these are the following two properties. On the basis of this, if there is a cycle in the linked list, the iteration will keep on going till infinity. In the second case, if there is no cycle in the linked list, it will end with null. This was the example with a no cycle. This is an example with a cycle. Let's say going to a node is like visiting that node. If we consider this list, we will visit the 3 first, then we will go to the 2, then we will go to the 0, then we will go to the minus 4. From minus 4, we will circle back to 2, to what's already visited. So we can safely say when a already visited node is visited again, that means we have found a cycle in the linked list. So the most intuitive way to solve this is that some way we know if a particular node is already visited or not while iterating through the list. The most appropriate data structure to use here is a hash set. Hash set has a unique property where putting into hash set has a time complexity of O of 1. Also, from retrieving from a hash set, it has a complexity of O of 1. So our algorithm will look something like this. If we see in this while loop, what we are doing is we are iterating through the complete list. However, while doing the iteration, we are checking if the particular element is present in our set or not. We have defined our set here. In case if the element is present in the set, we are returning it back from there itself. If the element is not present in the set, we are simply adding it into the set from here, and we will moving the head to the next element, right? Let's do a dry run of this. In this case, we will start from 3. From 3, what we are doing here is we are checking if if the set contains 3. Here, set is our empty. Our logic will move to the next line. It will come here. From here, what it will do, it will go and add into the set. So our set will have a 3 now. From here, logic will move to the next position, that is from head. Now head dot next. So head will move from 3 to 2. So we are at this position. Same thing will happen here. From 2, we will try to see if the 2 is present into set or not. Now this is not present. So we will try to put things into the set, right? So here we will put 2 into the set. Once 2 is put, we will move the head again. From 2, we will go to the 1. Same thing will happen here. 1 we will not find in the set, so we will add 1 in here. Same thing happened to minus 4. Since minus 4 is not into the set, we will add it into the set. Now from minus 4 we have moved to 2, right? In the 2 we will go to the while loop. Head is not equal to null. Here if you see the set contains 2, right? Since the set contains 2, we will return it back as true. If you remember, we talked there are two ways that this particular list will behave. Either we will find a cycle or we might not find a cycle. If we find a cycle, in this case, the logic will break here. If we do not find a cycle, then the logic will break here. So our iteration will go to the end of the list. So this is the right example to talk about that. I will do a dry run for this as well. So for this particular list, we have the head. It will start from A. For A, first thing that it will check if the set contains A. If it contains A, well and good, we will return it back. If it does not contain A, then it will put A into the set. Same thing will happen for B as well. The same operations will happen for B as well. Here, since B is not present in the set, we will put B. Again, same thing will happen for C, same thing will happen for D. However, when we reach to the D here, from D, the D dot next is equal to null. So it will come to this particular condition. This condition will fail. From here, we will come here. So this will return false. So the answer for this particular linked list will be false. Now let's try to find the time complexity of this algorithm. If we say in the worst case, we will iterate this complete while loop. So if there are n elements in the list and there is no cycle, we will iterate through all of the n elements. For that, the time complexity of this will be O of n. Now, if we say we are using an extra memory here as well. In case the list does not have a cycle, so this head will hold all the elements in the list. That means the space complexity of this algorithm will be O of n. With these complexities, can we do better than this? The answer is yes. There is a separate algorithm which is called Floyd Marshall algorithm or slow or fast pointer algorithm, which can help us to do this in a more performant way. The Floyd cycle of finding algorithm says that we need to define two pointers. One will be the slow pointer, another will be the fast pointer. The slow pointer will move one node at a time. However, the fast pointer will move two nodes at a time. So the algorithm bets that if we get into the cycle, the slow pointer and the fast pointer will meet at least at some point. You can take an example of a wall clock. If this is an hour hand and if this is the second hand, then in a particular day, considering the second hand moves faster than the hour hand, it will cross the hour hand multiple times, right? So the exactly same thing will happen here. Now let's do a simulation of this. Let's say the slow pointer we start from 3, the fast pointer we start from 2. This is where the slow pointer would be and this is where the fast pointer would be. So in the first iteration, the slow pointer will move with 1. However, the fast pointer will move to the 2 places. Let me write it down this as well. In the first iteration, from 3 we will move to 2 for the slow pointer. From 2 we will move to -4. Right? Accordingly, in the second iteration, from 2 we will go to 0 for the slow pointer. From 2 we are going to 0. For the fast pointer, from -4 we will go to, from -4 we will go to 2, from 2 to 0, right? Since this is going two places. So the first pointer from -4 we are going to 0. Now if we see this 0 and this 0 are equal. So we have found this, that means we have found a cycle in this particular linked list. Let's do the similar simulation for this list as well, which does not have a cycle, which has the end node as null. So in this case, what will happen? The slow pointer will move with 1. So obviously from 3, we will go to 2. Similarly, for the fast pointer, it will move from 2 to -4, right? So the fast pointer will move from 2 to -4. In the next iteration, what will happen is that from 2 we will move to 0, right? So our this will look like 2 to 0. However, the fast pointer from -4, there is nowhere it to go since there is a null. So this will move to null. So this is where our execution will stop. Since we did not, since the first pointer has moved to the null, that means we do not have any cycle in this list. So this is how our algorithm will look like. First, we will try to see if the head is equal to null. If head is equal to null, then we will return it as a false. The list with no heads, that means it does not have any cycle. Then we are dividing the slow pointer and the fast pointer. If you see, the slow pointer will come at the head. However, the fast pointer will come at the head next to it. I will define why we are doing this. Then this is the exit condition for our while loop. Here we are doing the while loop and the whole processing will happen here. So exit condition here is first is equal to null. In case we do not have a cycle for this particular example, the fast will reach here. If you remember, fast is moving with two places and slow is moving with one places. So obviously, if there is no cycle, then fast will end up fast will come to the end sooner. That's why I have written this particular condition for it. So if fast reaches here in this case and there is null after that, then we are breaking it from here. In case fast reaches here, from here fast reaches here, which is null. So it will break here as well. So these are the two conditions for it. Now, so in case of a cycle, so let's say that if you remember in the last example, the fast and slow was reaching here only, right? So if this equality will happen here, if slow is equal to fast, then we will return true. If this equality does not happen, then slow will move with a one pointer. This is slow dot next. However, the fast will move to the two pointers. In case we come out of this while loop, then we are saying that there is no cycle into it. That means the fast pointer have reached to the end of the list. So that's why it will return the false. So yeah, that's mostly about this solution. We will try to do this in the actual coding environment.
We had two solutions. So this is the code of the first solution where we are using a hash set. Now this set will keep the nodes which are already visited. Here we are running a while loop. This while loop will run till the end of the list. So here we are checking if the set contains this particular head which is now at the iteration. So if it contains, that means the node was already visited and we are visiting it once again. In that case we were returning as true. Otherwise we will add into the set and we will move the head to the next pointer. Let's see if this works. Awesome. Let's try to submit this as well. Cool. So it's taking around 4 milliseconds. Now this is our second solution where we are using Floyd's cycle detection algorithm. If you see here, the head is equal to null, then we are returning it as false. Here are the two nodes, one is the slow and fast one. So this is the breaking condition for our while loop. Here we are assigning the slow to the next element, the fast to the the second next element. In this case we are so if this particular case is does not satisfy, that means we have come to the end of the list. In that case we will say that this does not have a cycle. Let's try to see if this works. Awesome, this works. We will try to submit this as well. Awesome. After the submission we are getting into some 1 millisecond, right? For the earlier solution we had it's around 4 milliseconds, so this is a superior performance. That's it for this video. Thanks for watching.